Hello all. Uh, Welcome back to session 7 of Langchain. Uh, we have been started this 3 weeks ago. Now this is the fourth and last week today. So let us quickly recap what we have done till now. Then we are going to see what is today's agenda. All right. So in the session 1, we have done interaction with LLMs and as well as embedding models, right? Using a Langchain. In session 2, we have discussed about prompt templates, chart prompt templates, uh, dynamic prompt templates, static prompt templates. So related to prompt components, everything we have discussed in session 2, right? In session 3 and 4, we have focused mostly on RAG based applications. Especially in session 3, we have seen document loaders, different kinds of document loaders we have seen. Be it a text loader, we have seen a PDF loader, right? So we have also seen a CSV loader. After that, we move to chunking strategies in Langchain. We have seen length-based, chunking, character-based chunking we have seen, and recursive character-based chunking also we have seen. We have also discussed about semantic chunking as well, right? And the next session we discussed about vector DB. We practically implemented how to use Chroma DB, right? How to use Fiasys, uh, and then how to store vectors, how to do delete vectors, how to insert vectors, and also we have discussed about what are the retrievers, what are the retrievers in Langchain, how it works. So we have successfully discussed that, and we have built a small RAG application as well. So this is about week 3 and week 4's recap. Coming to the last session, week 5 and week 6 recap, we are purely discussed about LCEL, Langchain expression language. We have seen several kinds of chains. We have taken multiple examples of how to build chains in Langchain, right? And also we have discussed about runnables. What are runnables? We have discussed about runnable sequence, runnable parallel, right? And what is runnable pass through, runnable lambda. So what are main components of runnables we have discussed successfully. Along with that, we have also discussed what is memory, why do we need a memory component in Langchain. So these are week 5 and week 3 discussions. Now we have successfully entered into last week of these sessions, today and tomorrow. So let us quickly go through what is today's agenda, right? So we are left with tools and as well as agents. So today what we are going to do, we are going to start what are tools, and as well as what how to define the tools, right? So there are two kinds of tools are there in Langchain. One is predefined tools. It means already library itself is providing some set of tools. So we will discuss what are predefined tools, how to use those predefined tools, and also we are going to discuss about custom tools, right? So what is custom tool? How do you define a custom tool? All these things we are going to discuss. Coming to predefined tools, especially we are going to see what is a DuckDuckGo search of Wikipedia, how to use these predefined tools in our in Langchain, and also we will build custom tools, a simple calculator tool and as well as a weather tool. So these two tools we are going to build, and then we are going to see how to do a tool calling, single tool calling, and as well as multi tool calling. So these are the concepts we are corely cover into this session. If time allows, we are going to discuss what are agents, how agents works, what is the difference between chains and agents. So we till now we have built so many chains, right? We have taken a runnable parallel example, we have taken a runnable sequence exams. So many tasks we are able to build using chains, right? If we can do already these kind of tasks in chain, why do we need agents, right? So we are going to discuss that as well. So what is the difference between chain and agents, when to use a chain and when to use agent. Also we are going to uh, build a simple weather agent for first, and then we are going to build a capstone project, then we are going to end this Langchain session completely. In the capstone project, what we are going to build, we are going to build a PostgreSQL agent where you can talk to your database with a natural language. I'm going to cover both the modes. You can chat with them in text mode. Also, you can give a voice commands so that it will process your voice command and give you the output from your database. So this is going to be you know this week's agenda, right? So let us quickly wait for a minute and see if anyone will join, and then we'll start. I think, guys, there is a small mistake happened. Instead of live session 7, it is streaming in session 8. uh, it's okay, no problem. Let us continue and then see. Okay. So let us start with tools. What are tools? All right. What is tool? See, guys, a tool is a lang chain in a function or operation wrapped in standardized interface that an LLM can call. We all know how LLM calls work, right? We all know how LLM calls work. It is very simple. LLM will take the input and then process your input and then gives the output. So this is what we have seen from the session 1 to session 6, right? So uh, so when we are already interacting with LLMs by passing our inputs, why do we need tool, right? Let's say uh, if you want to interact with your systems, currently what is happening till now, what is happening? You are giving some input to the LLM, and LLM processing your output and giving the output. Your LLM is not interacting with any external, applications. Correct. So let's say you have something, you have already built some CRM system, or you are in your organization, you already have lead management systems or CRMs, or you have a database where LLM wants to access some data and then process. So these kind of things we are not doing till now. Till now what we are doing, we are doing a plain LLM call where we are capturing input from the user, and then we are processing, then sending, LLM is giving the output, right? So why we need tool means tool gives extra edge to interact with external systems. uh, you can think like this. So your LLM is a brain, right? Your LLM is a brain. But if you have a brain, you can understand, right? You can understand what we are talking to the LLM, but your LLM is not able to perform any action because it doesn't have, you know, tools with it. So in a simple terms, you can tell that your LLM is a brain of your application. Your tools are going to be your hands or legs, right? With these hands, how you perform some actions, your LLM also can interact with any external systems and can do some, some perform some actions. So this is how simple a tool is. A tool will give an extra access to either a data source like PostgreSQL, be it a MongoDB, be it you know MySQL. Uh, so you can wrap these data source into tool, and you can give the access to LLM so that LLM can get the data from your database and process it, right? Because user will not enter, user will only ask the question, right? And also you can using tool, you can connect your APIs. Let's say you have your CRM, right? When user is inquiring about your product, you want to display some form to the user where user can fill his name, right? His name, his email ID, or his phone number. So these are required, to capture any lead, correct? So as soon as user gives this information to the LLM, so LLM has to decide, okay, now I got the user details. These user details should be, you know insert into our CRM system so that our sales representative will take those information and will interact with the lead. Correct. So for these kind of operations, so what we are doing, we are integrating extra capabilities to the LLM using tools. Right. I hope tool concept is clear. If it is clear, then we will see how to declare tools and what are the uses of tools we are going to discuss. So it is very simple. If you want to, define a tool, what you have to do, you have to take from a Langchain tools. You have to import a tool class. So right now you no need to worry. We'll go to our Visual Studio Code where you can see a full list of tools. Right. So, all right, guys. So you can see over here why we need a tool calling, right? So LLMs by default are generators. They are specialized in generation of your output. They produce a text based on the probability. So they cannot make actual API calls. They cannot fetch any real-time data. They cannot execute any code. Let's say if you want to execute any code, LLMs cannot execute. They cannot read your databases, or they cannot interact with your external systems. So when you want to give all these extra capabilities to your LLM, then you need to implement a tool, right? All right, so I hope it makes sense. Now we'll see tool calling, when to use tool, we have discussed now, right? So without tools, what we can achieve? With tools, what we can achieve in Langchain? So without tool, LLM only generates text, right? So with tools, what will happen? LLM plus actual execution via tools. So we can interact with any external systems. So here there is no real data, or there are no, whatever user enters, we are simply processing, we are simply passing to LLM, and LLM processing your input and give the output, right? There is no real data. Whatever user is entering, you are just passing, correct? In the with tool, what you can do, you can get any real-time data like weather information, correct? Or you can do any operations. Let's say um, user is asking about, generally all LLMs supports 2 plus 2 how much. But in case if you want to give your own custom calculator tool to it, right? So you can, using tool, you can provide extra calculator tool, right? So you can, without tools it will prone to hallucination. With tools, what will happen? Your APIs or your database will give the result, and you will merge those results into context so that you can eliminate hallucination by using a tool, right? So if you don't use tools, it is a static response, because every time you ask a joke, it will give you the joke, right? So if you use the tool and you want to connect to any external systems, in that case you need to use a tool, correct? So this is about tools. Let us quickly go to our Visual Studio Code and then see uh, how to use. First of all, we'll see in built tools how to use. Then we will see how to build our own tools, right? So if any tool is not exist in the Langchain according to our requirement, then how we are going to build these tools? Correct. All right, guys. So let me open my Visual Studio Code. So I have activated my environment as well. So let me quickly create a new file which is called tools. Give me a moment. So I'm going to name this folder as a tools, right? Because we are going to discuss about tools. So now what I'll do, I'll quickly create a new file and give tools.ipyn. All right, guys. Okay. So first what we are going to do, we are going to discuss about how to use a pre-built tools, how to use a pre-built tools inside a Langchain. So what are pre-built tools and all there? Let us go to our Langchain document and see what kind of tools are already available in Langchain, and we will try to use those tools, right? Okay. So let me take a new code node, and also I'll take you to a LangChain documentation as well. So you can see over here, this is the official documentation. Just click on a tools documentation, then you will land up over here, right? So we will simply see, first things first, what we have to do. We have to import tool, that we will see practically. Then what we do, these are the custom tools, but we are going to do inbuilt tools. So we will see what are inbuilt tools are available, and then we will go to a custom tool. Just give me a moment, guys. Let me find out where it is, or let me search Langchain inbuilt tools. Or I can directly search Langchain DuckDuckGo tool. So this is one predefined tool in Langchain. Okay, all right. So you can see that one kind of pre-built tool is DuckDuckGo search. So what this tool does, this notebook provides a quick overview of DuckDuckGo search. DuckDuckGo search offers a privacy-focused search API designed for LLM agents. It provides a seamless integration with wide range of data sources, prioritizing user privacy and relevance search results. So in short, what DuckDuckGo search does is, DuckDuckGo search will give searching capability over internet to your LLM, over internet to your LLM. So now you can see that how to integrate these tools. So you have to install first of all DuckDuckGo search, right? After installing DuckDuckGo search, then you have to import this document. Is basically I think Node.js based document, but a similar thing we have to do it in Python as well. So let us quickly go and implement. After all right. So what we have done, we have to import our DuckDuckGo search first. Once we have imported DuckDuckGo search, we have to create a DuckDuckGo search class object, right? Once you create, then you just need to invoke. All how we are using invoke for every component. We have seen invoke for LLMs. We have seen invoke for prompts, right? We have also seen invoke in retrievers. So every component in LangChain is a runnable. We are already discussed yesterday, I think last week's class. And every runnable supports invoke method, right? So you declare a tool and then use invoke method to access those tools. All right. So first, let me define a tool. First of all, what I need one import which is from Langchain community dot tools. Langchain underscore community tools are exist inside Langchain underscore community package. From there, I have imported a duck go search run. Duck go search run is a class name. What you can do using duck go search, if you ask any question, LLM, if you ask any question, you can access any information related to that question in the internet. All right, all right. So after that, what we have to do once this is done, we need to declare this class. Correct. So let me quickly declare this class. So this is how you declare DuckDuckGo search run class. Once I have declared this class, let me assign this to some variables. So what I'll do, I'll take a variable called search. Search is my variable name. So now uh, this using this search reference object, I can use invoke method and I can pass any query to the this search. So once I pass the query, what will happen? It will connect to different data sources in the internet, correct? In the internet and then fetch the information. All right. So let us quickly see. Let me quickly take a query. Query is equals to. So you can ask anything. Basically, what I'm asking, I just ask what is a lang chain. What is Langchain? So this is basically my query, and using DuckDuckGo search tool, I'm going to extract some information about Langchain over internet. Correct. So let me quickly invoke my tool. How to invoke tool? It is very simple. You have to take your reference variable, which is that reference variable. Search is my reference variable, and then dot invoke. You have to use dot invoke. That's it. So not only DuckDuckGo search run, any pre-built tool, you have to follow the same procedure. First, you need to import that pre-built tool and then create a class of that using that reference variable. You have to use invoke method. Invoke method accepts your query. All right. So let me pause quickly query. All right. Yeah, there is a spelling mistake. Let me correct it. Paste it. So this how simple it is to use any pre-built tool. So now what I'll do, let me store. It will give some result, right? Let me store into some result variable. I'm taking result variable, and whatever this tool gives the output, that output I'm storing into result variable. Now I'm going to print that particular result. That's it. So let me quickly execute and show you. So for since these are pre-built tools and we might require some package to install, I will try to execute first if it gives any error, and then I'll see how to solve that error. Okay. So let me quickly execute. I have to select my environment, virtual environment. I have given same our Lang tutorial virtual environment. Right, started executing. Let's see what output it gives. All right. So you can see that as we expected, module not found error. So it needs some module to be installed, but that module currently not exist in our virtual environment. So what is the error? From ddgs import ddgs. So it is internally, it is trying to access a ddgs package, which we haven't installed, right? So you can clearly say that module not found error, no module named ddgs. So if you face any such kind of errors, what you have to do, immediately copy that error, either search it in Google, right? Or you can search it in chat gpt, so that it will immediately give you some suggestions. You have to take that suggestions and try to execute. Now it is a simple ddgs error. Let me try to install that package. Still if I get any error, then I'll use chat gpt and then solve this issue, right? Pip install ddgs. Let me execute it. So it is trying to install that particular package. All right, guys. So it has successfully installed my package. Now, since package is DDGS package is available, I am expecting this time it should not give that particular error. So let me run and see again. All right, guys. So now you can see that it has produced some output. This output is coming from where? This output is coming from DuckDuckGo search. We are not using any LLM. Remember, we are not using any LLMs, right? We are simply taken a pre-built DuckDuckGo search tool. We have declared one query, and then we are invoking our tool using query method, and that tool has given the result. So till now we are nothing to do with any LLM. So how it is giving result? DuckDuckGo search will go to internet, will connect to different data sources, and it will find what is Langchain, right? And then it will give you some answer. So let's see what is the output it has given. Langchain is a software framework, uh, the integration of large language models into applications. So it has given this kind of answer, right? So this is how you have to use inbuilt tools in Langchain ecosystem. All right. So now quickly take one more example. This time we are going to use Wikipedia tool, right? Which is also available in pre-built tools in Langchain ecosystem. So let us quickly use Wikipedia and then try to ask some queries and fetch some output. All, all right. So let me take a new code node, and then we need to take imports. A couple of imports we need for this. So let me quickly do that imports. So how I got to know about these imports? Simple. You open your browser, just search for Wikipedia tool in Langchain. Then you will find out the documentation. Copy those, just follow the documentation and try to implement. So not only these two tools are available in Langchain ecosystem. There are n number of tools are available. N number of tools are available. After this session, what you will do? You just go explore their document and try to invoke whatever tools are available, right? All right. So once this is done, then we need to declare a Wikipedia query run class. So this is the class we have to declare and assign to some variable, right? So what I'm doing, I'm going and then I'm declaring one variable called Wikipedia. Inside Wikipedia, I have instantiated the Wikipedia query run class. This class expects API wrapper variable. That variable I am passing as a Wikipedia API wrapper class. So since this is required thing, that's why there is a extra import. There is a extra import from utilities, right? So if it doesn't, if it is a plain, if it doesn't require this, then I no need to import this, since according to the document, it is a required Wikipedia API wrapper. That's why I have imported from Langchain underscore community dot utilities. All right. So it makes sense, I think. All right. Now what is the next step? We have a reference variable, and we need a query. Once we got the query, we need to invoke this Wikipedia variable. Correct. So let me quickly define a query. You can take any query, right? Let me take a query as a Python programming language. So you can give any query, no problem. All right. So this is my query. Now I need to invoke my Wikipedia search. All right. So let me write Wikipedia. All right. Dot invoke. Once you do dot invoke expects one input string argument, right? So let me pass this query string over here. All right. So if it is successfully invoked, then it will give some result. That result I'm going to store in a variable called res, and then I'm going to print that res. So that's how. That's it. So whatever tool it is, this is the three simple steps. You need to do necessary imports first. Once your import is done, you need to declare that particular class. Using that class variable, you need to use invoke method and pass your query. Right. All right. So once this is done, let me execute this. So if it requires, external packages, I need to install again. So let me quickly execute and see again. So again, we have got error. What is the error? No module named Wikipedia. So we need to install Wikipedia module, correct? So let me quickly install Wikipedia module. Pip install Wikipedia. That's it, guys. Let me execute it. That is going to install that whatever required package. Once this package installation is done, then we can invoke our tool. All right. So it has been done. So let me quickly execute now and see what output it gives. All right. So you can see that. All right, guys. You can see the output. What is the output? Page is Page is Python, and summary also it has given. Python is a high level general purpose programming language. From where this output we got, we are not interacting with LLM. We are not getting this output from LLM. We are getting this output from Wikipedia tool, right? So this is how any pre-built tools can use inside Langchain system. Now what we will do, we will try to uh, we will try to implement a custom tools. Custom tools. What is custom tools? Custom tool means you are going to define the tools, right? These tools you are not defined, right? Someone already declared these tools. You are simply invoking those tools. When you want to interact with your system, maybe you need to interact with your APIs, right? Let's say if you want to get weather information in Bangalore, that time what you have to do, you have to call weather tool, correct? But weather tool is not exist in Langchain ecosystem. In that case, what you have to do, you have to build your own tool, correct? So that is how you have to build your own tool. Now let's see how to build our own tool. Let's start with a simple adding two numbers tool, and then we will later we will discuss a weather tool and all, right? So I think it gives a better you know uh, better understanding of how to define tools. All right, so let me quickly take a new file. Now this time I will give file name as custom underscore tools dot ipynb. All right. So I have taken new file because we are going to start how to implement custom tools in Langchain. All right. So let me take quickly code node. I'll close this file now because we don't require this file. All right. So once your code node is opened, then what you need to do, you need to start declaring your tool. We have already discussed a tool is a simple function with a decoration at the rate tool, right? So there are several ways to implement our custom tools in Langchain. We are going to discuss a couple of ways and most popularly used one, correct? All right. So first what you need to do, you need to import the tool first. You need to import the tool. So what I have done, from Langchain underscore community dot tools package, I have imported tool. Why we have imported tool? Because we are going to, we are going to uh, build a custom tool. For that, you need to import tool. All right. So this is the first step. Once your first step is done, let's execute this. Select virtual environment. Second step is you need to define your function first. You need to define your function. So let me quickly go and define my normal regular Python function. All right. So let it execute completely. Still it is executing, I guess. Or let me do one thing. Quickly execute using another another virtual environment. If it gives error, then I'll use my own virtual environment. Yeah, it started executing. All right. So let me go back to my virtual environment, which is a Lang tutorial, and then execute. So before, let me take a new code tool. Still some problem. Just wait for a moment. Just wait a moment, guys. I don't know what is the problem. So if not working, maybe I need to restart my Visual Studio Code. Then it may work properly. Or let me do one thing. Let me take same thing in a new code node and start executing. All right. So this started executing. All right, guys. So this node has some error. So let me quickly delete it. All right. Now my tool import is done. Right. So this is my first step to define a custom tool. Now, second step is you need to define your Python function. So what kind of tool we are going to integrate at the beginning? I am going to integrate adding two numbers, nothing else. Just it will add two numbers and will give you output as an integer. It takes two integers as an input and gives one integer as an output. Inside function, I am going to implement addition operation, right? So why we are doing this? Because you will understand better so that you can in the later stage we can implement more complex tools, right? All right. So let me take a new code node and then regular function Python function I will define. Def add is my function name or add numbers is going to be my function name, right? It requires two inputs. One is A and another is B, correct? So let me quickly do it and then let me return A plus B. So this is how addition will do, right? It takes input A, input B, and then we are going to return A plus B. If you see over here, so currently our data type is any, right? It means this function may accept string or number or boolean, any value it will accept. So to avoid that, what we need to do, we need to give a particular data type what we are going to accept, correct? So I'm expecting int as as a variable, a variable, that's why I have given int. For B also I'm expecting integer type value, that's why I have given. If you know how to define function, in case you are returning anything, you can return what kind of data type you are returning, right? So this is a normal regular Python function, right? Nothing special. So this is going to be my second step. All right. So now I'm going to implement my third step. You can execute this function, will not give any error because it is a standard Python function. All right. So to make it a tool, you need to give some extra information, that is a doc string. A doc string you need to provide. So what is doc string? Inside doc string, you can give some information about this function, what this function does, right? So what this function does, it will two numbers add two numbers, then result the then return the result. So this is what this function does. It will add two numbers, then return the result. So why we need to provide a doc string? Because when we want to integrate this tool with LLM should understand your tool in a better way. So that understand will purely, depends on your doc string. Depends on your doc string. So you you always try to give a brief description about your function, right? So this is going to be my third step, right? What is my first step? I have imported a tool from Langchain community tools. Second step is a regular Python function I have declared, and third step is I have added a particular data types and then I have given a doc string to that particular function. All right, guys. So I hope it makes sense. Once this is done, now it is a regular function with the doc string and data types, right? It doesn't it is not any special tool or any special function. So now what I will do, I'll make this as a tool using at the rate tool decorator, right? So whenever you use at the rate a tool decorator over this function, it will act as a tool. It will act as a tool. So same syntax we might have seen in fast API, right? We might have seen in fast API. So we will take a normal function and we will use a decorator to expose it as an API, right? Same concepts we are using in tool as well. All right. So this is the fourth step. Now my tool is ready. My tool is ready. So let me quickly execute it. You can see that there is no error. It means my tool is ready. Now what to do? Once my tool is available, I can invoke that particular tool, right? So what is my tool name? Add numbers is going to be my tool name. Add number is going to be my tool name. So to give the brief idea about this, let me take a new node and then I will print my add underscore numbers. So let me quickly print it and see what it gives. So you can see that it has given a name of the tool. The name of the tool is add numbers, the same name we have given for our function, correct? And then description. Description will contain whatever a doc string we have given, that will be having inside description property. All right. So you can see the description, add two numbers, then return the result. So this is our doc string we have given. So that will be present inside a description. Now, third thing is args schema. Args schema. So schema, whatever schema it is required, that schema it has defined, and then some memory location it has allocated. That's it. So every tool will have three things. Three things. One is a name, another one is a description, and another one is arguments schema. So these are very important components in a tool, right? Uh, so these three will be present when you access trying to access your tool. This tool will have all this information. All right. So now let us invoke this tool and then see, because in earlier stage also what we have done, we have invoked inbuilt tool. Now what we are doing, we are invoking our custom tool, right? Let's take a code node and then do add numbers. This is our tool name dot. Now it supports invoke method. At the rate tool will make this as a runnable class, correct? Let me take invoke. Inside invoke, what it is expecting, it is expecting two arguments. Those two arguments you have to pass. So what it will see, you can see over here, either you can pass input string or a dictionary or a tool call. Input string we have already seen. Now input string we cannot pass here because it is expecting couple of arguments, correct? It is not expecting single argument, it is expecting couple of arguments. So for that purpose, what I'm going to do, I'm going to pass a dictionary and then I'm going to pass whatever the variables it is expecting. Here I'm going to give a 2 and then I'm going to declare another variable called b. That value is also I'm going to give as a 4 or 3, whatever you want. All right. So what we are invoking and then we are passing a couple of values. Because why two values we are passing? Because we are expecting, it is expecting two values. Now let's say if you don't pass b, what will happen? We'll see. It will try to execute your tool and you can see that there is a validation error. Why validation error? Your tool is expecting two arguments and you are trying to pass only one argument. That's why the error it has given. Now let me pass a second argument as well and then execute. Now you can see that your tool has returned some output. That output is 2 plus 4, which is 6. All right. So this is how you have to make your custom tool. All right. Now what we will do, we will go to our next step and then using a structured tool. Using a structured tool, there is a one more class called structured tool. Using that structured tool, also you can declare, you can define or declare a tool. So this is the one way of doing tool. Now we are going to see second way of second way of creating tools, correct? So let me quickly take a new code node take a code node. So this time I'm going to import different things because we are going to follow a different method to create the tool, right? So what is the different method? We are going to uh, define a tool using structured tool. So this base model and all, pedantic base model and all required. Why it is required, I'll explain going further. So let me execute these two imports first. All right. So I have declared these two. In this method, what we need to define a particular class. We need to define a particular class. That class we need to pass it as a function. So let us quickly see what it means. Let me take a new code node, and I am taking one pedantic class which is imported from base model. Inside class I have declared a and as well as b, right? So both, it is an integer variable, b also integer variable. Inside field, so now that's why we have imported field. Inside field we are giving a description. This is first number to add, the second number to add, right? So we have nothing done, we have simply declared a pedantic class over here. All right. So once you done that, now the next step is you have to implement your own function. So let me implement my own function. So my function is this: definition addition underscore numbers is going to be my function name, and this is expecting uh, one parameter a and another parameter b. Correct. Now earlier, if you see, at the rate tool decorator we have used. Here at the rate tool decorator we have used. Now we are not going to use at the rate tool decorator. Instead, we are going to use a structured tool to define our tool, right? So let me quickly take a tool name. What I'll do, I will take addition underscore tool is going to be my tool name. Once you have taken the tool name, then you have to call your structured, let me define this, a structured tool dot, you have to use form underscore function, right? Inside form underscore function, it accepts a couple of parameters. One is not couple of parameters, three, let's see what parameters it accepts. It accepts some parameters. The first parameter is going to be a function. Which function you are making as a tool, right? Addition numbers is going to be my function. Using a structured tool, I am making this addition numbers as a tool, right? So this tool name, this time it is going to be addition tool. If you use at the rate tool decorator, it is very simple and one line of code to declare a tool. If you follow structured tool, you need to implement some other pedantic classes, and also you have to use structured tool, everything. So in the end, what you need to use, it's up to you. You can either use at the rate tool, or you can use this structured tool as well. Both, in the end, both does a same work, right? All right. So now if you see this function I have passed, and then input schema. Input schema I have to pass. My input schema is this now, right? Uh, Variable A and as well as variable B. So that is what I'm passing in the input schema. So directly I'm passing my input schema class over there. All right. Now it will understand that it requires couple of arguments. The first argument is int, and also second argument is also integer. All right. Now after that, a name I have given, some name addition tool I have given, and then a description. What it does, adds two numbers together. So same thing, whatever we are doing here, at the rate tool will do all these things, right? But instead of doing at the rate tool, we are declaring everything in our own manner. So let me execute this. There is some error. Just a second, guys. Uh, 1 minute. I don't know what is the error. Let me execute. All right. So there might be some spelling mistake, I guess. Okay. So it has executed successfully. Now tool is done. Right. Now what we need to do, addition tool is holding our tool. Correct. So using addition tool, you can use your invoke method. Once you use invoke method, it accepts couple of arguments. You have to pass those couple of arguments and then it will give the result. That's simple it is. Now let me take a new code node. Now I'm going to invoke my this tool this time, addition tool dot invoke, right? So again invoke accepts couple of arguments. You have to pass it inside a dictionary. The first argument is going to be a, which is you can enter any value. 3 I am entering, and then second argument is b. I'm going to enter as a 5. All right. So now if we execute this tool, it has to return 8, right? That is what we are doing. 3 plus 5, it has to return 8. So let me quickly call it. All right. So you got the output as a 8. So this is how two ways, to define your own or custom tools, right? So let me also try to execute and see what this addition tool will be having. Just to print this addition tool, right? Same whatever we seen earlier, it will be having name, it will be having schema, right? It will be having description. All right. So now you can see a name it has, which is addition tool, and it has a description, which is add two numbers together, which we have given, and then argument schema, right? So this is how custom tools works. Now we will go further more. This time we are not going to see addition tool, subtraction tool, multiplication tool. These are very simple tools, you can implement easily, right? So do it as an assignment. You can try to define your own multiplication tool, division tool, and subtraction tool, since it follows a same structure. Now what we are going to do, we are going to build a weather tool. We are going to build a weather tool. So for that, what I will do, I'll go to a weather provider, which is Open Weather Map. Open Weather Map, who gives a weather information if you invoke their service. So we are going to Open Weather Map. There we have to create one API key. Using that API key, you can interact with Open Weather Map system, so that if you pass any query, if you pass any query, it let's say if you want to know weather information about Bangalore, then you have to pass that query to that particular tool. That particular will give weather condition about your city, right? Not only Bangalore, you can pass any city, be it a Bangalore, Delhi, or Mumbai, whatever it is, right? So let me go to open weather map. Open weather map, right? So if you type open weather map, it will give you open weather map.org URL. Just click it. So you just need to create one account in open weather map. Once you create the account, inside dashboard you can generate your API key, right? um, all right, so it has opened. So let me sign in, because I already have a account. So if you don't have any account, you can simply click on create an account. You can give your username, your email, your password, and repeat password, and then accept their agreement. Then click on create account. It will create the account. Since I already have the account, I am going to log into my account, right? Let me log into my account. All right. So I have signed successfully. Once you sign successfully, then you can see that these are the this is the dashboard of that open weather map. Not only open weather map, you can consider any service provider. So open weather map is one of service provider who gives the weather information, right? Just go to API keys section. Once you go to API keys section, I have a couple of APIs already, right? I will just copy one API key and then I will going to use that particular API key. So I just wanted to show you, in case if you want to create a new API key, just click on give a API key name and click on generate. It will straight away give you the API key, right? All right, all right, guys. So now let me take a new code node. Let us follow a similar thing. What we have to do in the step one, to define a custom tool, we need to import the tool, right? Once we imported the tool, this time we need to interact with OpenAI weather map. So we need to make one HTTP request. All right. So to make HTTP request, we need to import a library in Python called request. So let me quickly import that library as well. Why we are importing request? Because we are going to use http request to open a weather map uh, for getting weather information from their system, right? So that's why I have imported my uh, tool as well as import request. So let me quickly execute this. All right, so my imports are done. Now, once my imports are done, I need to define a function. So like this, I'm going to define a function. So what is my function? My function is going to be get weather. I will pass the city as a string, and then I am expecting output as a string about weather information about that particular city. All right. So now what I have to do, I have to take the URL. If you go to their document, if you go to that document, right, whatever we have seen here, so you can go to the services and documents so that it will give a detailed API document, right? Click on API. Once you click on API, it will take you to the API document. All right. So you can click on API doc. So once you click on API doc, it will give you a full information about how to access that particular API, including examples. So it is this is very simple. You just follow the document so that you will get the all information, right? All right. So I'm not going to show that because it is a simple API call. So if you follow the documents, you will get it ultimately. All right. So now what I'm going to do, uh, I'm going to declare a couple of variables. I'm going to declare a couple of variables. My variables, couple of variables are, one is base URL. This is the URL I'm going to use. So this URL, anyway, I got it from documentation. If you follow 2.5 documentation, you will get this URL. If you follow 3.0 documentation instead of 2.5, you might get 3.0. There will be a slight difference about 2.5 API document and 3.0 API document. Any document you follow, basically you see what are the required parameters. Those required parameters you have to pass. So what are the required parameters? Three required parameters it is accepting. One is Q, which is query. Inside query, I need to pass city name. Then second one, app ID, which is my API key, and then units. I'm going to mention a metric, right? So if you see my API key is not yet defined. So let me define my API key outside of this function. Anyway, you can define inside function as well. There is no problem, right? So I have copied my API key already, so that I'm going to paste over here. This is my API key for open weather map, which I showed now, right? So once that is done, once it is done, what we have done, we have declared API key, we have declared a function, and we have declared whatever required parameters. Now what we need to send a get request to this particular URL. For that, what I need to do, requests dot request.get. So it requires a couple of arguments. One is base URL and then params, right? So let me quickly pass a base underscore URL and then comma params. I need to pass params. All right. So base URL, this URL I am passing. Inside params, I'm passing my params. All right. Okay. Now Now what? So this will give some result. If this API call invoked successfully, this will give some response. That is that I'm going to store it in a response variable, right? So once it is done, I am converting it into a JSON. For that, I'm writing this line response.json. Now, if you want to see what data contains, you can simply print that data. All right. So this how simple you need to implement your open weather map to get any weather information about your you know any city, right? So the problem is this is going to give you a JSON format output, but what I am expecting my function, I'm expecting my function should return a string output, right? For that, what I am doing, I'm writing some logic. In the end, my function will return one uh, string instead of a JSON object, right? So if you want to return a dictionary, you can also return dictionary, but here data type you need to change. But instead of changing there, what I am doing, I am taking that data and constructing a new string, and this string I am going to return, right? So what I'm checking first, I'm checking whether it is a 200 or not. You know that HTTP status, I hope you know. If HTTP status is 200, it means your API call is executed successfully, right? If it is not 200, it means your call hasn't been executed successfully. In that case, what I am returning, I am sending that could not get weather for this city. There is some error, correct? So error, I'm instead of if response status code is not 200, I'm returning some error. Otherwise, I am returning weather in city. Let's say you send Bangalore, weather in Bangalore is 20 degrees centigrade or 15 degrees centigrade, whatever it is, and some description about that particular weather and what is the humidity level. You can also see if you print data once, you can find out what and all keys are available inside the data. Based on that, you can construct your return string, right? So let me quickly execute and see what this does. All right, so there are no errors. And why we are not getting data? Because we are not invoking this particular function. All right, so first step is done. Now what we need to do? We need to provide a doc string, right? We need to provide a doc string. We haven't provided a doc string. So let me quickly provide a doc string. This is going to be my doc string. What is my doc string? Get current weather for a given city returns a simple human readable summary about temperature, description, humidity, and etc. So this is going to be my summary. Once this is done, I need to decorate it with at the rate tool. Correct. So let me quickly decorate with tool. Now this will become tool. Now what I can do, I can use this get weather and I can use invoke method, and if I pass a city, it will try to invoke this tool and give me the particular output. All right, so let me go there. So now let me re-execute again so that it is become a tool now. Now I want to access this particular tool. How you can access this particular tool? Take a new code node and then one second. Take a new code node. What is my tool name? My tool name is going to be get weather, right? So I'm copying my tool name get weather, and then I'm going to use dot invoke method. So let me quickly use dot invoke method. So this time my function is accepting a one parameter, which is a city, right? Which is city. So what I'll do, I'll pass a dictionary. Inside the dictionary, I'll mention a city and make sure this city name should be according to open weather document, right? So let's say in normally for Bangalore they will declare it as a Bengaluru. So what I'll do, let me quickly add as a Bangalore. So this is how traditionally we write Bangalore, but actually this is not the correct city name, right? Its correct city name is Bengaluru. So let me see what output it gives, whether it will understand or not. So you can see that COD 404 city not found. Why it's city not found? Because this is not the official spelling of Bangalore. Official spelling is going to be Bengaluru. So this is what official spelling. So now what I will do, I will try to invoke this tool. Now see the output. All right, now you can see that it has produced some output, right? So make sure whenever you are passing some city name, you go to open weather map document. There you can get all list of, you know, cities which are available with their database, correct? So if you ask normal simple cities, you may get 404 error, because that particular city weather information they might not be having, or there might be a spelling mistake. All right, so just ignore this for now. This is the our actual output, right? What is our actual output? Our actual output is weather in Bengaluru, 21.79 degrees centigrade. This is the short description about weather. It is telling that mist, and humidity is 73%, right? So this is we are constructing, right? If you see my tool, if you see my tool clearly, we are constructing this string. We are constructing this string. This is not the actual output. Actual output is coming here inside data. So that data also I am printing. That data also I am printing, correct? You can see over here, this is the data. So there is so much information. There is a coordination information, what is the longitude of Bangalore city and the latitude of Bangalore city, and also it has given weather information. So this is the description mist what we are displaying over here, correct? Description we are displaying over here. And then some other information, some temperature also we are going to we are displaying here, which is 21.79 degree centigrade, right? It is feels like, even though it is 21.79, it feels like 21.93. If you want that information, you can display that as well. So minimum temperature was this and maximum temperature was this. Might be this is for this particular hour or this particular day. So I'm not sure. So in might be in this particular hour, this is the minimum temperature and this is the maximum temperature. And the pressure, humidity, sea level, what is the sea level, ground level, visibility, wind speed. There are so many things are there, right? So I feel this information and all not required. So I mostly concentrated on a city name, a temperature, a description, and as well as humidity. Right. So that is the reason I'm just returning uh, only these particular parameters instead of returning all this metadata. All right. So we have successfully created our weather tool as well. Right. Now uh, once this is done, there is a one more concept called a toolkit. There is a one more concept called toolkit. So what is the difference between tool and toolkit? Uh, Toolkit gives a list of tools. That's it. Toolkit gives a list of tools. Let's say you are developing a calculator as a tool. You have several functionalities, right? In the calculator, you will be having add, you will be having subtraction, you will be having multiply, you will be having division, you will be having so many operations, right? So instead of exposing every tool to the LLM, you can simply expose your calculator toolkit. Uh, a toolkit, right? Toolkit basically contains a list of tools which are present over here. So let us not waste much time. We'll simply quickly see what is toolkit and how to do it, and then we will go for a tool calling, right? So again, I'm going to import my tool, which is available inside Langchain underscore core dot tools, right? I have imported a tool, and since I'm showing calculator toolkit, so I need a couple of functions, or 3 or 4 functions. How many functions I want, I can declare, right? So let me quickly declare a couple of functions, which is add and multiply. Later, if you want, you can also add some more functions like division and subtraction as well, right? Just a minute, guys. So all right guys, I'm going to give two tools. So I'm not going to explain because we have already seen this add tool. We have given the red tool decorator. We have given a doc string, and then we are returning a plus b. For multiply, we are doing same thing. We are expecting couple of parameters. We are returning integer, and we are doing returning a multiplication by b, and then we have declared at the rate tool. Correct. So now these two become a tool. Now let's see how to make a toolkit. Correct. Let's see how to make a toolkit. So for making a toolkit, you need to declare a new class. Declare a new class. So let me quickly declare a new class. This class name you can give anything. I'm going to give a calculator toolkit, which is a meaningful name for this, right? So here what I'm doing, I have defined get underscore tools as a one function, and inside that function, I am returning whatever tools I have declared over here. So I have couple of tools, so I am returning couple of tools. If you have a 4, you have to return 4, right? So quickly execute it. Before that, I need to execute this, and then I need to execute this. All right. So once this is done, then you can call these tools. You can call these tools. So let me take this calculator tools class. So let me click a new code node. You can see that calculator toolkit I'm assigning to toolkit. From toolkit I'm calling a get tools function. So it will give list of tools. Dot tools I'm storing inside the tools. So to check what and all tools are available over here, I'm just going to add this for loop because it is going to give list, right? List of tools it is giving. So I have given a for loop, and then I'm printing each tool name as well as description. In case if you want input schema want to be printed, you can also print input schema as well. All right. So let me quickly execute it. Okay. It has executed successfully. Now you can see that I have a couple of tools. One is add and one more is multiply. Add two numbers. This is the description of this add tool. Multiply two numbers is the description of multiply tool. So this is how you need to use a tool kit. I just wanted to show the toolkit, so that's why I have shown. In the end, what toolkit does, it will give a list of tools. That's it, nothing else, right? All right, guys. So we have successfully completed pre-built tools, and we are also successfully completed how to define custom tools and how to access this custom tools. Right now, let's see tool calling. Let's see a tool calling using LLM, right? Till now, we have seen a tool calling simply with dot invoke method, right? With the dot invoke method, we haven't involved any LLM here, right? Now, what we will do, we'll go one more step further. We'll try to add these tools to the LLM, right? These tools to the LLM, and LLM will decide which tool to use. LLM will decide which tool to use. Correct. So we are adding one more intelligence layer. Let's say we have a couple of tools. We have a couple of tools, and user asks some question to the LLM, and LLM will decide, right? Based on the user query, LLM will decide whether to access these tools or not to access these tools, right? Based on the query. So let's say I have given a tool called addition of two numbers to the LLM. Now, my user comes and says hi, right? For this query, there is no need of using my addition tool, correct? Because my addition tool, if you use, there is no sense of using this tool because it is a simple greeting. So LLM will decide, okay, this is a simple greeting. I should not use the tool. So it will say hi. It will say hello. How are you doing today? Something something. It will generate some response and it will give. But let's say this time user ask what is 3 plus 3? What is 3 plus 3? Now LLM is intelligent enough. Okay, user is asking about some calculation, and I have addition tool with me, That tool expects two arguments A and B. Now I have 3 plus 3. A is 3 and B is 3. So let me call this tool. Let me call this tool and then get the output from the tool. Then based on that output, it generates its own output. Okay, the result of 3 plus 3 is 6, but our tool is returning only 6, right? So this is how in a real time it works. So let me quickly take you one example so that you will understand in a better way. So now what I'll do, I'll take a new function code, and I'm going to call this as a calling underscore tool dot ipynb. All right. So calling underscore tool dot ipynb. This is going to be my file name. Let me quickly select virtual environment, which is this, and then I'm taking again weather example. Extra what I'm doing, I'm going to have an intelligence layer, right? So what is that intelligence layer? We are going to add one LLM. All right. Just a minute, guys. Someone is asking, sir, please add today's code in GitHub link so we can use. Sure, sure. I'll make sure all these files are available in GitHub link. You no need to worry about that. So definitely our capstone project and as well as whatever files we have used till now, everything will be available in the GitHub. I'll make sure today or tomorrow it will be available in the GitHub. Right? No need to worry about that. All right, guys. Let us see quickly what are the imports required. So again, we are going to use a weather tool with LLM. So that's why I'm importing a tool. I'm importing a request, and then I'm importing chart OpenAI as well from Langchain underscore OpenAI. Let me quickly execute this. So it is going to execute. Then whatever the function I have declared earlier using a weather tool, same function I'm going to declare. Right. So let me take a new code node. I'm just copy pasting from earlier version. I'm not doing anything. I have gone to our custom tools. So whatever we have done earlier, same thing we are doing. All right. Now what I have trimmed over here, instead of we constructing, I am going to return a data this time. So whatever data we are getting from Open Weather Map, same data I am going to return. Why? Because this time I have a LLM. My LLM will be taking care of what information to show, what information not to show. We can also follow earlier step. There is nothing wrong in it. You can also, why I am returning data, because in the earlier case we are clearly constructing, right? If you see over here, if you see over here, manually we are constructing a readable string, right? So I don't want to do that. I want to show you how LLM works, right? LLM has to construct this kind of output for us, right? We no need to construct. So for that purpose, what I have done, I have deleted all this extra logic, whatever we are doing over here. I have deleted extra things, and then I'm simply returning data. I'm not doing anything, right? All right. So my function is ready. Let me execute it. So my tool is ready. I have decorated with @tool decorator. Now what I need one model. Let me quickly create a model. So what I'll do, I'll take a parameter variable called model, and then I'm going to declare chart open AI. Right. All right. So we have seen all these things earlier. I'm no need to explain again and again. All right. So once that is done, I'm going to invoke this model. I'm going to invoke this model, and I will ask what is the weather in Bangalore. What is the weather in Bangalore? So guys, if you observe carefully, I have just declared the tool. I haven't tell to my LLM anything about tool, and then I'm trying to get the weather information. See what model response. If model response, if it says that it doesn't know, or if it says that it cannot access weather information, then I will show you how to, how to bind this tool to the LLM, and how LLM accesses this tool to get the information, right? So for clear understanding, right now I am not binding any tool to my model, right? I hope you got my point. So let me invoke this model. We all know model dot. We need to use invoke method, and I'm going to ask a simple question. What is the weather in Bengaluru? Earlier case, if you see, I'm directly passing city. I'm directly passing city as Bengaluru. This time my question is different. What is weather in Bengaluru? What I am expecting, my LLM will, if I give the tool to my LLM is intelligent enough to find out, okay, he's asking about Bengaluru and this tool accepts city as an input. So I need to extract Bengaluru and call this tool, right? So that is how my expectation. We'll see how it works. First, let me print the response. So I'll store it into response variable and then print this response. If you want to see only content, you can do it response dot content, right? All right. So let me quickly call it. All right. You can see the weather is in Bengaluru is generally pleasant throughout the year due to its mild tropical climate. The average temperature ranges from 15 to 35 degrees centigrade, the summer months. So it has given generalized answer. It has given generalized answer. But what we are expecting? We are expecting what is the exact weather in Bangalore, right? What is the exact weather in Bangalore? So here you can see that we have a 22 degrees centigrade current weather and humidity is 73%. We are expecting a real time information from the LLM. But since LLM doesn't have access of weather info, it has generalized that Bangalore will have mostly what it say here due to mild tropical climate, the average temperature ranges from 15 to 35. So generalized answer it has given, but this is not the answer I am expecting, right? So for the now, what I will do, I am going to bind my custom tool to the LLM. Correct. I am going to bind my custom tool to the LLM. So this is what my tool. Till now, I haven't given any information to my model saying that you have a weather tool. In case if you want any information from this tool, you can invoke that particular tool. But that information I haven't told to my LLM till now. That's why what my LLM thinks, my LLM giving a general output. Now I am going to bind my tool and see what output LLM changes. Correct. So let me quickly take a new code node. Let me take a new code node. So this time I'm adding a new variable called LLM underscore with tools. LLM underscore with tools. Right. So this time what I have to do for this particular model, I have to bind my custom tool. I have to bind my custom tool. For that, which method I need to use? Model dot bind method I have to use. So you can see over here, model dot it's not bind, it's bind tools. Model dot bind tools. Inside you need to pass a list of tools. There is no restriction that you can pass one tool, you can pass two, three, four. How many tools you have, those many tools you can pass. Correct. All right. So what is my tool name? My tool name, since I used at the rate tool decorator, my tool name is going to be get weather. So let me copy it. Let me copy it and then paste it over here. So this is my tool. Make sure you are not passing in single quotes. If you pass it in single quotes, that will become what? It will become a string, right? So this is not a string. This is a function. That's why I am not passing inside quotes. Now, now my binding is ready. My binding is ready. So this time what I'll do, I will try to use LLM with tools instead of simple model. Simple model doesn't have any tool access, but LLM with tools is having a get weather tool access, right? So same query I'm going to copy again. Let me copy it and then paste it. Let me copy and paste it. Now you can see over here, it is saying that uh, again, what is weather in Bangalore? I am asking to, instead of model, I have to ask to LLM with tools. Why? Because model doesn't have any tool information. LLM with tools having a tool information. Right. All right. So let me execute. Now see the content. Content you will not all right. So it is not printing any content, right? Because it doesn't have content now. It will try to access your tool. That's why it is not giving any content. So what I will do? Let me quickly de delete that content. Now I'm printing a plain response. I'm printing plain response. Just execute. You can see that there is no content has been produced. No content has been produced. It means LLM is thinking I should not give any answer. Instead, I can give information saying that there is a tool called weather, there is a tool called get weather. Using that tool, I have to execute that get weather tool first. That get weather tool will give some information. That information, I have to take it as a context and then produce the final output. This is how LLM thinks. This is how LLM thinks, right? So now, if you see over this output carefully, there is a content which is empty. Additional rag, some metadata it is there. For now, just ignore this metadata. What I want to show you is, just a minute, guys. I want to show tool calls. All right. So you can see over here, tool calls. There is a there is a parameter in there is a key inside response which is a tool calls, and it is giving a list of array. What it is telling, I you have there is a tool name called get weather. Pass arguments as a city Bengaluru. Did we mention anything city Bengaluru? No. We have given a plain text. What is weather in Bengaluru? LLM understands and make a dictionary, arguments dictionary, which is city Bengaluru. And it has assigned some ID, right? And type. What type it is? It is tool call type. So it is intelligent enough. What I want to say is it is intelligent enough to understand I need this tool invocation. I need this tool invocation. So if you just want to see about the tool information, you can simply call a response.tool calls. Response.tool calls. Let me execute it. I can clearly see that it is telling that we need to access a tool called get weather by passing these arguments, dictionary as an argument. The tool id execution is going to be this is the id, and then type is tool call. So that's why you have seeing content is, you know, empty this time, correct? So now quickly, because on behalf of LLM, what we are doing, we are going to invoke that particular tool. We are going to invoke that particular tool. So when agents comes into the picture, right, that's that time we'll see how to autonomously execute these tools. But right now I want to show it manually so that you know, you will have a clear idea. Okay, when we assign tool, what is happening in the background, right? LLM is not going to call your tool. LLM is not going to call your tool. LLM only gives, okay, this is the tool I want to use. Then this tool will give me the, you know, better context. This tool will give me the better context. So that is how it will give the response. Now what will happen, your framework, your Langchain framework or whatever NIDN framework, whatever you know, agentic framework you use, those frameworks will take responsibility of executing these tools on behalf of LLM, and then will pass that particular output to the LLM. Now LLM has the context of a tool result, and then based on that context, it will produce the output. All right. So right now I want to show you manually because you know, you should get a clear picture. You should get clear picture what is happening in the background. So for now, what I want to understand you is LLM won't call your tools. LLM only gives the information. this particular tool need to be called, right? Then your framework, in this case it is a Langchain, will be responsible for executing that particular tool. So this point I want to clear you, right? So uh, I want to show you practically, that is how I'm doing it everything manually. When we are using Langchain, we can Langchain framework will taken care of executing these tools, right? As of now, let us do manually everything now. So now I have a tool calls. So let me execute this tool manually. What I'll do, let me invoke this. So let me take a new code node. So in new code node, what I'm going to do, I'm going to invoke my get weather tool, right? So invoke is my function. Invoke I have taken. So invoke has to pass some arguments, right? Where is that arguments? That arguments are here. Either you can extract that particular arguments and pass, or you can simply pass this dictionary. Your tool will able to get whether will able to extract this particular arguments as well. Now what I will do, I will pass this response tool calls to this. If you observe carefully, this is list of a dictionary, correct? List of dictionary. This is one dictionary. In case your LLM needs multiple tool calls to be executed, at that time you will get one more dictionary, right? But this get weather tool has to be executed only this particular dictionary, right? Not all dictionaries, right? For that, what I'll do, I need to tell that execute only first dictionary, correct? Which is in zeroth index. All right. So now it is done. Once this is done, this tool is going to give some result. Now this time I'm going to call this as a tool underscore result. Tool underscore result. So don't get confusion. Earlier what we have done, we are doing everything, we are passing city, only city, but this time we dependent on LLM is telling that execute this tool by passing these arguments. We are doing same thing. All right. All right. So I'm going to print this tool result as well. Print tool underscore result. Tool underscore result. Now let me execute this. Now you can see that this is the output my tool has given. Why this is the this JSON output is coming? Because I am returning a complete data this time. I am returning complete data, right? What our tool gives, that complete data I am returning. I am not constructing a string and returning. That's why we are able to see this full data. This full data. Now, if you see this type of tool result, if you see this, what type what type of variable this tool result, let me take a new code node and print just a type of print a type of tool underscore result. Print type of tool underscore result. Execute. You can see that this is a type, data type of tool message. What data type it is? Tool message. We already discussed three types of messages in earlier sessions. One is human message, second one is a system message, and third one is AI message. Now we are going to see a new type of message, which is a tool message. This is not a AI message, this is not a human message, or this is not a system message. This result is coming from tool. That's why this is a tool message. That's why this is a tool message. I hope it makes sense, right? I hope it makes sense. Now what I'll do now, now I'm going to invoke my model by passing tool message, and then my LLM will construct a final output and will give us, right? So I'm taking a new variable. uh, Let me take a new code. So what I'm doing, I'm this time I'm doing my final query. Inside my final query I have taken a formatted string saying that the weather data is coming from tool result, right? You can see over here, this is my tool result. It is holding all this information, right? Now I'm telling to my LLM saying that the weather data is here, right? And user question is this one. What is the user question? Sorry, user question is different over here. Let me quickly copy it. This is the user question. Now simple, whatever we are doing in a RAG system, we are doing same thing, right? So user question was this. User question was this. Just a minute. Yeah. So user question was what is weather in Bangalore? And then I'm telling summarize it. Summarize it. Now let me access my model. Model dot invoke. I'm going to pass my final query. I'm going to pass my final query. You can also use same what LLM with tools also you can use, or model also you can use. There is absolutely no problem at all. All right. Now I'm going to consider it as a final result. I'm going to consider it as a final result. Let me print over it. Final underscore result. Final underscore result. Right. All right, guys. So let me execute this. Connection server. I don't know. Let me execute this. All right. Now you can see the model output. The weather in Bangalore is currently misty. Misty is coming from where? You can see over here. Weather description is mist, right? So that is how it has taken the reference currently misty with a temperature of 21.2 degrees centigrade. What is the here 21 point, let me show you the temperature. You can see over here 21.2. The same it has applied here, 22.2 degree centigrade. It feels like 21.39 degrees centigrade with a minimum temperature of 20.80. So using all the information, it has constructed a beautiful, output. All right. So why it has given? Because I am giving the context to LLM this time, but earlier case, this is the output, generally pleasant throughout. Earlier case, we are not providing the tool information. That's why it's failed to give exact weather information in Bengaluru. But this time we have given a tool access, and we LLM told us to execute this tool. We executed the tool, and then we have given that particular tool result as a context. Then LLM made a final result, which is what we are expecting, right? So this is how manual tool calling happens. Manual tool calling happens. All right. Now I hope you got the point. I hope you got the point. If you want to practice some different cases, you can try it. Instead of Bengaluru, now pass it Mumbai. Right? There is some other tools also you can pass it. Now, what I will do? Let us dig further more. Let us dig further more. What I'm going to do is, let me take a new code node. This time I'm taking a couple of new imports, which is I'm taking a model, chart OpenAI model. I'm taking a tool. This time I am declaring a human message, AI message, and tool message. So using these three messages, how we can construct the final output, right? So I'll quickly explain. It will not take much time. So this time what I'll do, let me execute this. It is got executed successfully, and then I have taken a new code node. This time what I have taken, query. I'm not taking a direct query. Instead, direct query, I'm taking human message. I'm trying to use this human message, AI message, and tool message, right? So I have taken a human message, and then I'm asking what is the weather condition in Bangalore. Now, messages I have taken inside a list, correct? Inside a list, I have taken this query. All right. Now what I have taken? I am using LLM with tools and then invoking by passing this messages. What is this message is having? This message is having currently human message. Currently human message. After that, whatever response comes, that response I am going to add it inside my messages. Currently, my messages is having human message. Once we are interacting with AI, correct? It will be having AI message as well, right? So let us quickly add and see what output it will be having. Now, give me a moment. Let me quickly execute this. Now this is the human message. Human message is what is the weather condition in Bangalore, right? Now if you see all the metadata, you can also find there will be a AI message. Let me show you. Just a moment. Tool calls it has successfully given. So all right, this is the AI message. You can see over here AI message. So what is AI message? AI message content is empty, but it is telling that use the tool, use the tool, right? So now what I'll do, let us use the tool using our using our response, correct? So let me quickly take a new code node and then write this function. What I'm doing here, I'm invoking my get weather tool by passing whatever I got inside my response. My response, I got tool calls. That first tool call I am taking, and then the tool result, whatever I got the tool result. That tool result again I am going to put it in messages. Messages a list. So at this point, this messages is having human message as well as AI message, right? Two messages it has. After tool call, what I am doing, I am appending one more message, which is tool result, which is type of a tool message, which is type of tool message. Now I have technically in messages, I have three messages. One is I have a user query, correct, which is human message. I have AI message. Currently, content was 0, and then I have content is empty string. I have a tool result which is having weather details about Bangalore. That will be in a tool message, right? That I am appending to message, and also I am printing message. Now I will show all three types of messages it will be having. Correct, correct. Now you have a human message over here and all weather information is there, and you also having AI message as well, right? Now now I will try to invoke my model instead of earlier case what we have done. Let me show you what we have done earlier case. If you observe, we are constructing the query again, right? We are constructing the new prompt again, but in this case what I am doing, I am not constructing the new prompt. Whatever earlier conversations happened, whatever earlier happened, what is a human message, what is a AI message, what is a tool message, everything is having inside message. That message I am passing, I am not telling anything to the LLM itself will understand. Okay, first user asked about what is weather condition in Bangalore. So content I have given an empty string and saying that execute this tool. Now this tool has been executed and I got the tool message. Correct. Now what I need to do? Okay, I need to access the tool message. I need to access the human message. uh, Based on human message and the tool output, I need to construct the final output. That final output it will give you. That final output where I'm storing into final result, and then I'm printing final result dot content. I hope it makes sense. I hope it makes sense, right? So let me execute it. Now you can see it is beautifully constructed the response. What it has constructed: weather condition Bangalore, temperature is this much, description is this, humidity is 77%, and wind speed is 6.71 milliseconds. Right. So this is how your LLM gives the output. All right. So I hope you all understand what is a tool, how to call a tool, and then how to send a tool message to the LLM so that LLM takes this context and give you the final output. Now, we have seen a single tool, right? We have declared a single tool and we are asking a question. It is very easy for the LLM to understand, okay, I have one tool, user is asking about this tool. So let me call this tool. No, this time what we will do? We will do multi-tool calling, right? What I'm trying to say, let us declare a couple of tools and then bind our LLM with couple of tools, and LLM will decide based on the user query what tool to use, right? And in this case, we will get a more clarity. In this case, we will get more clarity, right? So let me quickly take a new file, and this time I'm going to call this as a multi underscore tool underscore calling dot IPYN. All right. So let me take my virtual environment. So it has taken. Let me take a new code node as well. All right, guys. So let me take same imports we have seen earlier. So this time what I am doing, I will give weather information also, and I also give a DuckDuckGo search also. DuckDuckGo search tool also, right? So one tool is going to be my weather tool, custom tool, and one more tool is going to be a pre-built tool. You can also pass both as your custom tool. It is you can do mix and match whatever you want. You can pass as a tool, right? So I thought it will make much sense if I pass one free pre-built tool and one custom tool, so that you can get the better understanding. Once this is done, let me quickly import it. Let me quickly import it. Now, yes, my imports are done. So let me take my DuckDuckGo search. So let me take a new code node. I have taken a DuckDuckGo search run. We have seen earlier how to execute this, right? So I have declared a search tool. Now search becomes my tool, right? So in case if you want to see, you can print the search, print SEARCH. It will be having all information about tool, being your tool name, your description, and what argument schema you are expecting, right? So let me execute it. Now you can see that uh, API wrapper, DuckDuckGo search. Maybe inside this, it will be having this particular tool information. So now let us declare one more tool called, which is the tool weather tool, right? So I'm not doing anything. Again, I am copy pasting earlier code itself. I'm not doing much over here. So let me take a new code node and then declare this. All right. So I've taken a second tool successfully. You can see that get weather is going to be my tool. Correct. So my first tool is DuckDuckGo search and my second tool is weather tool. All right. Now let me execute it. Let me execute it. It is executed successfully. And then taking new code node. This time what I will do, I will ask a different question. I will ask a different question where it can access both the tools. For one, I will merge. Basically, what I want to show you is I will merge two questions and I will ask as a single question. Like I will ask what is the weather in Bangalore and who built the Mysore Palace. Now you can clearly understand who built Mysore Palace uh, has to access our DuckDuckGo search, and then what is the weather in Bangalore has to access my weather tool, right? So let me ask that question and see. For that, what I'm going to do, I'm going to declare my query and my query is going to be very simple. What is my query? Inside query I have taken a human message and asking the question. Actually I'm merging couple of questions. First question is, what is the weather condition in Bangalore and who built the Mysore palace? Correct. All right, so once this is done, let me take a message variable. Inside message let me store my query. What I am trying to do here, I'm trying to maintain history of human message, tool result, and AI message as well. Correct. So that's why I have taken the one a list of messages. All right. Now I am also trying to access this time a system message, and I am telling, see what will happen if you what system message I am telling. Use tools only. Use tools only to give answers. Use tools only to give answers. Why I am mentioning here? If you don't mention that system message, what it will do, right? Who built Mysore Palace? LLM will be having its own knowledge base, right? From there, it will pick the answer. From there, it will pick the answer. So I want to avoid that. I want to avoid to pick the answer from LLM knowledge base. Instead, LLM has to access my DuckDuckGo search tool. So that is the purpose I have given system message here and telling to LLM, uh, use only my tools. You don't use your knowledge base to answer my questions. So that is strict instruction I have passed over here. All right. Now I'm going to create a model variable. Here I'm going to take my chart open AI. Correct. Chart open AI is going to be my model. All right. So model has been successfully defined. Now what I need to do, I need to bind my tools. I need to bind my tools. How you bind the tools? Using a bind tools method. Using bind tools method. All right. So I have taken a new variable called LLM with tools, and I have taken model reference, and then I'm binding a couple of tools, which is my get weather tool and as well as my search tool. Right. Search is my DuckDuckGo search tool. Get weather is my weather tool, my custom tool. All right. Now, now I will invoke this. I'm going to invoke it. All right. So LLM with tools, I'm invoking by passing message. At this point, my message will be having a couple of information. One is human message and second one is system message. Right. Nothing else it has. Nothing else it has. Now, once it gives the output, I'm going to append AI message as well. I'm going to append AI message as well. All right. So message dot append this response I am appending so that now messages will be having three: human message, system message, and as well as AI message, right? So let me quickly print this response and also show it to you. Sorry, instead of response, I'm showing you a message. You can also print and see the response as well. Print response. You can also take a new line or let me give empty print so that it will give a new line. All right. So let me execute it. Name error. Just a second, guys. There is a spelling mistake, it seems. Chart OpenAI. We have imported all the things. So, chart OpenAI is not defined. Let me do one thing. Just a minute. I don't know. Might be a spelling mistake, I guess. All right. So, let me execute. All right. So now first one is having my response. You can see that content is not having anything because it is depending on a tool response this time. Correct? Because I have clearly instructed use only tools to give the answers. Now also you can also see what is my tool calls. So let me print my tool calls. Let me do one thing. Let me take the code node and then I'm going to print. I'm going to print what I'm going to do. Earlier we have seen, right? We are printing tool calls. Just a minute, guys. response dot tool calls, right? So let me copy it and then save it. Now let me execute this. Now you can see that this time LLM wants to execute. LLM wants two tools to be executed. The first tool name is get weather. First tool name is get weather. What are the arguments it requires? It requires city and city name is Bengaluru, right? And the tool ID, tool execution ID is this. And then what is the type of this? Type of this is tool call. All right. Now the second tool name is DuckDuckGo search. Second tool name is DuckDuckGo search. And arguments, how beautiful it is constructed. See, uh, query is going to be who built Mysore Palace. All right, it has given a query as well, and then it has given ID, and then it has given a type as a tool call. Now, in the earlier case, we have a single tool to be executed, but now we need to execute multiple tools. We need to execute multiple tools. So for that, what I'm going to do, I'm going to add one for loop. I'm going to add one for loop, and each tool's output I will append to messages. I will append to messages. I hope it is making sense why we are using for loop, because this time I have two dictionaries. We don't have a single dictionary, right? If you have a 10 tools, it might ask you to execute 10 tools, right? So now I have two tools. It is asking me to execute two tools. Now what I'll do, I will quickly take a new code node and start writing one for loop, right? For tool underscore call in tool underscore call in what is my what I want to iterate. I want to iterate my tool calls, right? In the first iteration it will be having get weather. In second iteration it will be having my duck duck go search, correct? All right. So now what I'll do, I will write as if tool underscore call. This is the tool underscore call. If this name is matching with get weather, name is matching with what is my tool name, get weather, right? So here you can find out my tool name. My tool name is get weather. Just copy paste it over here, copy paste it over here, and then colon. Then I'm taking a new variable called let me add colon over here also, tool underscore message one, because I want to execute two tools. So I'm taking a tool message one and tool message two so that it makes sense. All right. Message one is going to be my get weather tool. Get weather tool, I need to invoke it. I need to invoke it by passing a tool call, this complete object. This object will be having args also, so that it will extract this argument schema and pass the city Bengaluru to my tool, right? So this will give you one output. That output I am storing into tool message one. Now since I am tracking all the outputs in a message variable, I want to also track this tool message. That's why I'm going to take messages, same variable, whatever I have used. It may give spelling mistake. That's why I'm copy pasting here. Copy over here and then paste. Dot. I need to append this tool result as well. Correct? Which is tool message one. All right. So this tool result I'm successfully appended to my messages. Now, second tool also we need to execute. For that, I am taking one more if condition. One more if condition. Let me copy paste it here. Now, instead of get weather, this time I need to execute DuckDuckGo search. DuckDuckGo search. If you have a 10, right? If you have a 10 tools, basically your for loop will be having a 10 if conditions. All right, because you don't know what needs to be executed. If you have to loop it, what wherever name matches that particular tool, you need to execute and you need to append it to your messages object. All right. All right. Now I'm taking instead of a tool message one, I'm going to take a tool message two, or you can give a proper names like get weather result or search result like that. Anything works fine. No problem at all. All right. All right. Now I need to append this as well. So for that, I'm going to append this. This time I'm going to append message to output. Message to output. All right. Now this is done. So now what I have to do, I have to run this particular for loop. Since I have a two tools, I added two if conditions. If you have a five tools, you can have five if conditions. Correct. All right. Let me execute this. Mhm. Sorry guys, it should not be get weather. It should be duck duck go search. There is I forgot to edit this. All right. So let me execute it again. Mm, Again error. Again. Oh, sorry. My tool is not duck duck go search. It is basically holding in a search variable, right? All right. So execute this. Now it is successfully executed. At this point, my message will be having a four out, technically not four, five. What is five? One is my human message, second one is my system message, third is my AI message, and then fourth and fifth is going to be my get weather tool message and my DuckDuckGo search tool a result as well. Let me quickly print my messages and see what output it is having. So this is the messages I want to see. Let me print over here. So you can see there is a human message. There will be a AI message. Correct. There will be a AI message. If you go to end, you can also see there is some tool information, which is this tool information. Let me show you clearly. Just a minute. Yeah. So get weather information it has, and also one more tool message also it is having, right? So tool messages also it is having successfully. Now what I need to do, all this context, all these messages I need to send to the LLM. Now LLM will decide based on tool message. It will decide the output and it will give the output. All right. Let me take a new code node and then store my final underscore result, final underscore result, which is going to be LLM with tools dot invoke, LLM with tools dot invoke, and then I'm passing all my message history, right? Right from the beginning, all it is having. It is having AI message, it is having human message, it is having system message, it is having a tool one message, it is also having tool two message. So now this all information acts as a context to the LLM. From this context, it will try to answer the question, right? So let me print my final answer as well. Final result, I'm going to print it. All right, guys. I hope it makes sense. Now let me execute it. Bad request. Um, just a minute. There is a error somewhere. I don't know what went wrong. Maybe LM with tool spelling mistake or something will be there. Let me check out. LLM with tools spelling is correct. Absolutely nothing wrong. Let me execute one more time. Uh, it is telling there is a error. Just give me a minute, guys. Let me solve this issue. I don't know what error it is. Invalid parameter duplicate value for tool call ID. I think there is something wrong in tool calls. There is something called in tool calls. We are passing a duplicate tool call ID somewhere. So what I'll do, I'll quickly execute this one more time. Okay, let me execute this. All right, I have executed it, and then I'm executing this again. Uh, There is some problem. Okay, let me execute from starting everything. I don't know what is the issue. Uh, if not solved, we'll use GPT to execute. GPT to solve this issue. Let me execute everything from scratch and then we'll see what will happen. Execute my query is also executed. Since it is a print statement, I'm not going to execute that directly. I'm doing a tool calls. Once tool calls is executed, I'm invoking my LLM. All right. So there was some tool ID duplication was there. I don't know. Might be I have did some wrong. So now you can see that the current weather condition in Bangalore is misty, and it is getting from my get weather tool. Also, the Mysore Palace was built by Kingdom of Mysore, southern India, founded around 1939 near modern day city of Mysore. So this information is also coming from my tool, right? So this is how tool calling will happen in real time. So general perspective is what is general perspective? Generally, people think that LLM is calling all these tools, but in real case, LLM will not call any tools. LLM only gives information saying that I need to execute these tools. I need to execute these tools. Then either you have to execute these tools manually, or what you have, or if you use any frameworks like a Langchain, Langgraph, or N10, these frameworks will do this tool calling on behalf of you, and then you will get the final result. So to show all these things, uh, what I want to tell you is, now I hope you will get a clear understanding of tools, how to call these tools, who will call these tools. I think I hope all these points will be cleared at this point, right? So with that, our tool and tool calling concepts are over. Then let us quickly see what else pending is there, and if any simple topics are there, we'll try to cover it. Otherwise, we'll postpone it to tomorrow. All right. So let me open my agendas today. Just a minute, guys. Let me open my agenda. Yeah. So we have successfully discussed what is tool calling, how to define tools. We have also used predefined tools, and we have also used custom tools, right? So we have discussed about DuckDuckGo search. We have discussed about Wikipedia, a simple calculator tool we have discussed, weather tool we have discussed. We have discussed tool calling as well as a multi-tool calling. Now, what is pending? Only pending thing is what are agents, how these agents works. So tomorrow we are officially entering into agents concept, right? So till now, whatever we have done, we have covered individual components of Langchain. We have covered LLMs, we have covered we have covered prompt templates, we have covered document loaders, we have covered text splitters, right? We have also covered vector databases in LangChain. So we have covered each core concepts of LangChain in detail. Today we have also covered what is tool and what is the use of tool, how to call these tools. Tomorrow we are going to discuss what is agent, you know what is the difference between agents and chains, when to use chains and when to use agents, right? After that, we are going to build a simple weather agent. Why simple weather agent I am building? if you see today's class if you see today's class, most of the tool work we are doing manually, right? Most of the tool work we are doing manually, but if you use agent, all these things happen autonomously. It means you don't need to do anything, right? Your you know your framework will take care of all this orchestration, and then in the end you will only see the result. You no need to do, right? You no need to take tool calls, you no need to write the for loop. Why I have done all these things? To get the better idea what is happening in the background. For that purpose I have shown this. But tomorrow when you build a simple agent, when you build a simple agent, uh, you don't need to manually execute any tool. All orchestration will happen by the framework. I think it is uh, uh, at this point, you are clear whatever concepts we have discussed till now. With this, I'm going to end this session. And tomorrow's agenda I have cleared already, right? If you see my agenda, so we are going to create one simple agent which uses a weather tool and then gives the weather information. If you see, once you know how to create a simple agent, you can create any kind of agent, not only weather. You can take your own custom tool and bind that custom tool to your agent, and your agent will take care of everything, right? And second thing is, we are going to discuss about a capstone project where I'm going to show you using a agent in Langchain how to interact with your PostgreSQL, right? Not only with chatting, we are also seeing voice command. Voice command. What does I mean? Let's say if you say to the system, if you give a voice command, how many users are present in my database, your voice command will convert into text, and that text will be executed by the agent and will give you the final result, right? So this and all, no need to discuss now, because I just want to give the glimpse of the project. That's why I have told. In tomorrow's session, we are going to cover in detail about our capstone project. First, we are going to cover what is agent. We are going to cover differences between our chains and agent, and also we are going to cover a simple weather agent using Langchain, and then we are going to create our capstone project where I am using one HTML file also, so that we are exposing our agent to fast API. From HTML page, we are accessing our agent so that it works like a real project, right? So tomorrow, instead of HTML page, your company may use you know Angular to build the front end part, or React it might build. It depends, right? Once your agent is exposed to fast API, you can use any front end framework tool, and then you can start interacting with your agent. So all these things we can see it in tomorrow's session. I hope we have covered all the things whatever expected for today. It is done. That's it, guys. I'm going to end this live now. Thank you so much for your time. I will make sure today or tomorrow all these from session 1 to now, all files will be available in the GitHub link. You can take those things as a reference, and you can start building your own, a project. Instead of using capstone project, you build for your own other tool. You take a MongoDB as an example, you try to build that, correct? You take some other use case and try to build it. That's how you learn and you understand better, instead of practicing whatever we say in the our session, right? All right, guys, thank you so much for your time. I'm going to end this